Hi and welcome to this video about capturing a window or the entire screen. So in this video I want to demonstrate how you can capture a window. Could be any window that you see on your desktop, and how you can do that, and even how you can capture the entire screen if you so desire. And so in order to do that, we need to create a project as usual. Going to write some code to do that kind of capturing. Now, I'm not saying this is the only way to do that, and in fact it's not the best way, but it is a way which is reasonable enough and works in most cases. So let's call that a capture window, and I'm going to put that in my YouTube code folder. It's going to be a console application as usual, and let's see how we can do that. So you might be asking yourself why would you want to do that to begin with, and you can find various reasons why you might want to do that. Some of them might be good reasons, some of them might be not so good reasons, but still could be useful. In any case, this is what I want to focus in this video. So first we have the usual windows.h include, and then I'm going to write some functions. So first let's write a function that's going to capture a bitmap for some windows. Let's call that capture window. It's going to accept a handle to a window and return an H bitmap, which is a way to identify a bitmap in the world of the graphics device interface, or GDI. I'm going to use this old graphics API for this purpose. It works, or at least it mostly works. I'll talk about some other options later on. So let's see how we can do that. So first thing what we want to do is want to know what the size of the window is, so we can create the appropriate size bitmap. So we can call the function getClientRect to get the client rectangle of the window. This doesn't provide the full window, it doesn't include the title bar. If that thing exists for that window, we can also work with the title bar if we want using the getWindowRect, but it complicates things slightly when calculating sizes. I'm going to leave that as an exercise for the interested viewer. Once we have that, we want to create a bitmap. Before we do that, we need to get a device context. So a device context is an abstraction that represents some kind of painting surface. So you might be familiar with similar things in other graphics APIs, like a rendering context in OpenGL, or a device context in DirectX, which is implemented very differently, but still the idea is the same. It's an abstraction, which means this device context can point to a window, can point to a bitmap, can point to a printer. And this is nice because it means I can use the same drawing APIs to draw on whatever that thing is pointing to. In this case, I'm going to get a device context for the window because I want to get information from that window. I want to be able to read the graphic aspects, the drawing in that window. So we have a device context, and the next thing to do is to create another device context. Well, in fact, we need to create a bitmap. So let's do that first. Let's create a bitmap. That's the thing I'm going to eventually return from this function. I'm going to call the function createCompatibleBitmap. And this creates a bitmap that is compatible to a particular device context in terms of the actual number of colors and bit depth and things like that. And since we have the width and height of the window, we can just grab it from the rectangle. And I just use RC right and RC bottom here, and that's okay because RC left and the RC top are always 0 when you call getClientRect. If you call the getWindowRect, you have to do the calculation by using RC right minus RC left and so on. This is the slight complication there. So I'm calling createCompatibleBitmap, creating a bitmap in the appropriate size, and then we can move on. The next thing to do, we want really to read from the window device context and stuff it into the bitmap. In order to do that, we have to put the bitmap into its own device context. So we need another device context actually. It's something called the memory device context. We can call the createCompatibleDC function to do that. So we're going to create another device context, but it's pointing to something in memory. Right now it's pointing to nothing. Technically it's pointing to a bitmap with a 1x1 pixel size, which is of course useless. We're going to call the selectObject function to select the bitmap into the device context. So now when we do something with that device context, then we're actually doing something on that bitmap. So that's the thing here that we want to do. And it seems that something is not happy here in Visual Studio. Let's try to build and see where things might have, well, and that's because, of course, this is an H bitmap and not just an HDC. So it's a handle to a bitmap. Okay, so now we've done this selection. The next thing to do is to actually transfer the bits from the window to the bitmap. I'm going to use the function bitblit, which is short for bit block transfer, that performs this copying operation in some way without changing the size. And since we created a bitmap with exactly the size of the original window, we don't really need any kind of stretching or shrinking of the bitmap. So the target first is going to be HDC mem. That's our bitmap, which is selected into this device context. We want to start with the beginning with 0, 0, and the size, of course, is known. So we want to do the full size there. The source of the bitmap, the blit operation, is the window itself, which is HDC, which is the one that we got for our window. And then we need to also specify where we would like to start in the source window in this case. So I want to start from the beginning. There's nothing special I'd like to do here. And the last parameter is indicating how would I like the bit blitting to occur. And there are various options that are supported. The simplest one is called src copy, which just means I would like to copy the source to the destination. That's it. So it's just going to be src copy, and that's the simplest one to use. In fact, that's what we want. And at this point, we can just return the bitmap. So we have the bitmap HBMP here. Should be ready to go. If everything goes as planned in this code, then everything should be just fine. If you really want to be vigilant, we need to release stuff. So we can use something like a release DC to release the device context we got for the window, and just to do proper cleanup. We can also do delete DC to delete the device context of the memory, the one that's holding the bitmap. We just leave the bitmap as the only live thing. Okay, so assuming this works, we need to do something else. We want to do something with this bitmap. So let's save it to a file. I think that would be the simplest thing to do. Let's just save it to a file. So let's go ahead and use maybe a little boolean here and call the function save bitmap. We're going to accept an H bitmap and some path. So here's some path to save into, and we're going to select a particular format like PNG, but we could technically use other formats. So now the question becomes, how do we save a bitmap into a file, an H bitmap like that from the GDI space? And again, there are several options. I'm going to use the best option that is available out of the box in Windows, which is using a component called the Windows Imaging Component, or WIC. And this provides lots of functionality in terms of working with bitmaps by converting formats and other things like that. So first we're going to add an include for this purpose. And this is in wincodec.h. This is where the WIC stuff is defined. And we're going to use smart pointers for COM, because the WIC API is COM based. So we just have to use that. So let's include the ATL COM client, which is my favorite, providing my favorite smart pointer, CCOM-PTR. And we're going to start with something called the WIC imaging factory. So everything starts with a factory. And once we create this factory, we can create sub-objects as needed. And so I'm going to just use the co-create instance function. And in this case, we have a class ID for that. It's called WIC image factory. So I'm just going to grab it and use co-create instance here. If this fails for whatever reason, then of course something went terribly wrong, and we can just return false here. In fact, I'm not going to do any kind of real error handling here. I'm just going to assert for every operation that we do. Once we have the factory, we can start our actual work. And the actual work is to create a bitmap from the WIC perspective. And the factory has a method called create bitmap from H bitmap, which is exactly what I need, because as it happens, we have an H bitmap to work with. So I'm going to pass this H bitmap that we get as a parameter. We need to pass a few more details, such as a palette, which is irrelevant here because we don't have a palette. We're using true colors, that is 24-bit colors or 32-bit colors. So a palette only makes sense when you're using 256 colors or less, which means it is irrelevant. And then we need to provide some information about alpha, how to access or how to use the alpha channel. I'm going to ignore that. I just want the actual thing, because the bitmap doesn't really support alpha to begin with, so that would be kind of pointless to provide anything else. And then we get back the bitmap, which is an iWeak bitmap interface. So let's go ahead and provide it here, and we're going to get a bitmap here. If anything is wrong, of course will fail. So I'm going to just use ATL assert here and say that I expect HR to be a successful one. So now that we have the conversion of the bitmap from GDI to a bitmap that Weak understands, we can start doing the next stage, which is perform an encoding. Encoding means taking the actual bits and writing them to somewhere, in a particular format. So for this purpose, again, we have the factory to help out, and it has a factory method to create an encoder. We need an encoder here. We need to provide the kind of encoder that we want. It's represented using a GUID. In this case, what we want is a particular format, and like I said, I'm going to go with PNG, but of course you can see other formats are supported. In fact, custom providers can extend this to support new formats that perhaps are not provided out of the box by Microsoft. Then there's an optional GUID vendor, which we don't really need. This is providing us with some ability to have more flexibility to select maybe one of multiple providers that know to work with PNG. In this case, null means we don't care, just give us something that knows how to work with PNG. And then we get back a weak bitmap encoder. So let's go ahead and put an ampersand encoder here and create another smart pointer, which is going to be the encoder interface. So that's going to be bitmap encoder, like so. And again, I'm going to provide HR here and add this assert just to make sure this works as expected and we didn't make any kind of mistake. So once we have that, the next thing to do is to initialize the encoder. So the encoder has a function called initialize we have to call, and you can see here that it has two parameters. One of them, the first one, is a stream pointer. iStream is a COM interface representing an abstraction over a chunk of bytes. And so the saving operation we're going to do can work on any iStream implementation, which provides flexibility. It doesn't have to be a file, it can be a memory chunk or something else that implements the iStream interface in some way. So obviously we need to provide some kind of implementation for the iStream interface, which we'll do very soon. And then there's some caching options we can specify. In this case, we don't care about caching. We just want to write everything into the file directly. So I'm going to have a weak bitmap, I think encoder, no cache or something. Let's just use that. So where I'm going to get an iStream interface. So I have a COM pointer here for iStream, but where am I going to get such a stream pointer? Since I want to write to a file, we need some implementation that abstracts a file using an iStream pointer. Fortunately, we don't have to work hard to get such an implementation. There's a function like that already built into Windows, is part of the Shell API. So the first thing we're going to do is perhaps add an include here where this function is. I think it's Shell WAPI or something. And the function is called sh create stream on file ex. That's the function. So this function provides the implementation for iStream over some file. Since we have the file here as a parameter, I'm going just to pass that in. And we have to provide a few more flags here that are required. These flags are from the structured storage or combined file implementation, something I've written about in a blog post a couple of months back. So if you're interested, you should look at that. In any case, we need to do some flagging here to make them correct. So first we want to create the file if it doesn't exist. We want to be able to write to the file, obviously, because we want to write to it. And we can also just share that as exclusive, just to make sure that nobody else can access the file while we're working with it. So that's going to be the mode there. And then there's some file attributes we don't really care about. We want to create the file always, which means that basically it's always going to like override the file if it exists already. And then there's some information about the template file, which we don't really care about. And finally, we get back the stream here as representing that file. So once we have that, we have an iStream implementation now, and we can pass it along to the initialize function of the encoder. And again, we can do the right thing and at least do some asserts, making sure this works as planned. Okay, so an encoder is initialized. What's next? So the encoder is again a kind of abstraction, and it allows us to write multiple frames because some formats support multiple frames like GIF and TIFF. And so in order to actually do the work, we have to create a new frame. So I'm going to call the function create new frame on the encoder. We're going to get back a parameter that represents the frame. So we need to capture that information, and we can also get back information about the property bag, which allows us to set various properties that could be some custom properties that might be supported by that particular encoder. In this case, we don't have anything special to set, so I can say that I don't really care. And so the pointer here is to another interface that's called iWeak bitmap, in this case frame encode. So it's a specific frame that we want to encode here. I'm going to call that frame, as we can see here. So this is again something that's supposed to work. Let me just assert to make sure. Now we have a new frame, and the only thing left to do basically is to write the information somehow. Before we do that, there's one more thing we have to do. There's another initialize function here. Let's just do that. And again, it allows us to provide some properties that we might want to use, but we don't have any special properties here. So the last thing to do is to do write source. So write source says, hey, give me a source bitmap. So that's going to be the bitmap we created initially based on the GDI bitmap. So we have that, and finally it's time to actually use it. And we can also provide a rectangle if you want to just save part of the bitmap. In this case, I want to save everything, so I'm going to use null here to indicate the entire bitmap. And we can assert for that as well. And we're almost done. The last thing to actually do, if I had more frames, I would create more frames and write more sources and so on. But in this case, of course, we just have the one bitmap. The last thing to do is actually to commit the information. This is kind of information that is cached within these COM objects. And when you call commit, they actually do the thing when taking into consideration all the stuff that has been stuffed into them, like the properties. So we need to commit every frame and also commit the encoder to actually do the final closing of the source. And now we're truly done. So we can return true here. Hopefully everything should be good to go at this point. Okay, so let's just go ahead and compile first to make sure everything is fine. So it's almost fine. We have a linker error. Apparently the sh create stream on file ex is not referenced in one of the imported libraries. We have to add another library here. Let me do that. And I've looked this up in documentation. The library is called, just like the name of the header, it's shlw API. So I'm just going to use that. As an import library that is provided. It's just not part of the default ones that we get in a new project, a new console application project. And everything compiles and links just fine. So it's time to try it out. So let's go ahead and give it a shot. So the first thing I'm going to do is to create a bitmap by capturing some window. So we need to capture some window. We need some handle to window here. So let me go ahead and get one. So here's handle to window. We need to get some value here, which we don't have just yet. We'll add that momentarily. And if that works, then the next step would be to actually save that bitmap to some kind of file. So here's H and some kind of file. I'm going to just put that in some directory I've created here called images. And let's call that, I don't know, in fact, let's use the handle itself as a name, or let's just for now just select something like pic.png, like so. And we're done. So we're almost done. We do need some handle here for some kind of bitmap, for some kind of handle to a window. So we have to get a handle to window. So how are we going to do that? So first, let's choose a window to capture just for fun. So here's regedit. Why not capture this window? how do we know what the handle window of the window of that window is? What is the handle value? So one way to do that is use a tool that I have called the WinSpy. So WinSpy is one of my free tools you can find in my GitHub repository. And the purpose of WinSpy is to show information about Windows in terms of those rectangular entities, not the operating system. So that's the term Windows here. It's very similar to the Spy++ tool you might be familiar with as well. That is part of the Windows SDK and has been around for many years. This is slightly better in certain aspects, but regardless, you can also use Spy++ for this purpose. So you can see there's various windows here, and some windows have child windows. Here's the regedit window. You can see it's handled to window, that's 1E2070. If I double click, we can get some properties of that window, including the handle itself. So I can just copy it here by pressing Ctrl+C. And you can see some properties of the window, for example, the fact that it's actually visible, and some other properties which are known as window styles, which is part of the way the classic Windows styles work, which is slightly beyond the scope of this particular video. So I have that window here. Great. I'm going to move it aside so it doesn't interfere. I'm just going to paste that in the handle itself. And so the window is now on my other screen, which is fine. We're supposed to see what we've seen right now. So let's try it out. Let's just press F9 here to press the breakpoint and run this, just to make sure that we get things working correctly, because we've done lots of coding here and maybe doesn't work as we expect. So I'm going to capture the window first, and you can see we do get some kind of handle to a bitmap, and I'm going to assume this is just fine. Then I'm going to just use save bitmap here and hope for the best. Okay, so apparently something went wrong. There's a false here apparently, so obviously this didn't really work out. And if we look at images here, we can see that nothing has been created. And the reason is that I forgot here to call the coinitialize function. Probably that's one reason, at least, that is we have to call coinitialize on every thread that does any kind of com work. And since all the weak stuff here is com work, Concrete instance has no way of succeeding without coinitialize. So let's try this again. Running this again, here's our breakpoint, F10, we get a handle to window, that's fine. Another F10, we get the handle to the bitmap, and now save bitmap returns true. So that's a good thing. Let's go to images, here's our picture, let's see, and this is what we get. So you can see we capture the client area of the regedit window. As you can see it right here, it's the same, exactly the same thing. And we can do the same thing with other windows as we see fit. For example, we can capture maybe the actual this window itself, the images window right here. We can capture that. Maybe we can try that, see what that looks like. And again, we need the handle to that, so we need to find that images. So here it is. You can see the handle. I can grab it again with copy paste. I'm going to go back here to my code and paste in that address and try this again. This time it's about the Windows, sorry, the images directory there. So let's see, we have here, I didn't change the file name, so it's the same file name. And here goes, you can see it grabs the client area of the window, which in this case contains the caption as well. This is just because the caption is drawn in a different way. It's not really the classic caption. So this seems to work pretty well, seems to work fine. In fact, we can take it a step further maybe and capture the entire desktop. Maybe want to capture the entire desktop, not just a particular window, but maybe capture the entire desktop, and we can try that. Let's try that. So I'm going to call the function getDesktopWindow that returns the desktop window. So I'm just going to pass that window to our usual capture window and save bitmap function. So let's try this now. So here goes, we get a handle to that desktop window. In fact, we can see it's the root window here, right there in WinSpy. We see that is the first window. That's the top window that is the parent, sort of the parent of all the other windows, so to speak. And then I'm going to press and just F5 and run all these things to the end. If you go back to a picture here and see what's going on, so what we find here is that actually it captured my other screen, my left screen. and that's because it is my primary screen, but didn't capture the second screen, even though it's still part of the desktop. As it happens, it seems like the function get client rect here doesn't work well with the desktop window and only returns the client area, or really the window area of the primary monitor. So if I want to capture everything, I need to do something slightly different, and that slightly different is calling another function called get window info. So get window info provide lots of information about a particular window in one fell swoop with a single API, and as it happens, it behaves more consistently for windows without giving any special treatment to the desktop window. So if I do that, and in this case the rectangle, I can grab that from that structure, and that's going to be within one of the members here, like RC client. So I can grab this thing right here. So no, don't need this call right now. In fact, I don't need it at all. We can just remove it and see if that works better for our desktop window. I'm going to press Ctrl F5, just run it in one big swoop, so you can see the file size is greater, which is a good sign. And now if we look at the paint here, you can see that now it actually captures both of the screens. You can see here that's my right screen, which has the Visual Studio we're running right now. So that's one thing you might notice in case you're looking at capturing the desktop window. Now, of course, you can do very interesting things. For example, you can have a timer that captures the foreground window every so and so seconds. You can do that. You can do that pretty easily. You can have a little loop here that captures a window, and of course in this case you probably want to create a file name which is dynamic in nature and is based on some formula, like considering the time that the capture is being taken or some other dynamic parameter. Then you can sleep for a while, let's say for 3 seconds. But of course you're not going to get desktop window here. You're going to call something like get foreground window. Get foreground window allows you to get the handle to the current active window. So when windows are get switched, you get the actual foreground window. You can capture that image and then save it or do something else with it, or send it to somewhere, whatever you might want to do with that. So that's something that is fairly easy to do, and you can try this out on your own. I do want to point out one limitation of this technique that we've seen here for capturing a particular window. So here's an example where these things might break down a little bit, and this has to do with UWP processes. And so, for example, here's a calculator window, and that's a normal calculator. We can get to the window, by the way, using WinSpy, not just by searching for it. We can actually use window find here to drag this little icon on the window in question that we're interested in. So I'm dragging that and then dropping, and we get the handle to the window. That's the one. And so we can see some properties, all the usual stuff. So now I can go back here, and instead of using get foreground window, I'm going to go back to my first approach by just pasting the handle to the calculator window and then capturing it. I'm not going to do any sleep here. Let's just break here. We just want to have a single capture. So here's my calculator. I'm going to even put it here on my other screen just to make sure that nothing obscures it or something. Let me press Ctrl F5, and we can see the calculator is here. Let's look at the images, and you notice the image is completely blank. It's completely, there's nothing. And so this usage of GDI doesn't allow us to capture UWP windows. One way to get around that is to capture the entire desktop. The entire desktop doesn't have this problem. So if I go ahead and go back to my idea of capturing the desktop window, you notice that even though I have a calculator here, let me put that on my other screen so it doesn't obscure anything here. So we're done, and I'm going to look at the image, and you can see here, we should see calculator right here. So right here, and since we know the coordinates of calculator, we can definitely just kind of copy just the part that we want. So we can just go ahead and and select the particular part we want and crop it out, say that that's what we want. And of course, we don't need to do that in Paint. We can do that programmatically because we know the coordinates of the window by calling get window rect. We can see where it is in the bitmap, and then we can just copy that particular part. That's one way to get around that. As a final thing, I want to say that capturing the desktop in this way, it's not the most efficient way of doing that, because it's using GDI, which is not the fastest thing you can do today, because the environment, the desktop, is actually being drawn by the desktop window manager, which dwm.exe, which has its own way of working. So Microsoft created in Windows 8 another API called Desktop Duplication, which is more efficient in capturing the entire desktop. I refer you to the Microsoft documentation to see more details about that. So this is it. I hope you enjoyed this capturing of windows. Feel free to play around with the code as usual.